High-quality asphalt pavements don't just happen. They're a result of thorough preparation, good communication, and most of all, the inspector's attention to the details. In this second part of asphalt paving inspection, we'll look at mix delivery, placement, compaction, and transverse joint construction. We'll start with delivery of the mix. The first thing to do is collect the delivery ticket from each haul truck. The ticket tells you the type of mix, the weight of the material, the time the truck left the plant, and in some cases the project number. Your job is to record the time the mix was received and where it was placed on the job. You'll need this information later to calculate the amount of material placed. You should also compare the gross vehicle weight with the weight shown on the delivery ticket to be sure that the trucks are not overloaded. Some agencies require you to reject overloaded trucks. Check the contract documents to be sure. You'll remember from part 1 of this course that there are 2 ways to deposit the mix at the project. The conventional method, where the haul trucks load the paver directly, and the windrow method, where the trucks dump the mix in a windrow and a pickup machine feeds the paver. In both cases, it's important that you inspect the mix as it arrives. Your first concern is with temperature. Too high a temperature can damage the asphalt binder in the mix. But if the mix is too cold, as you already know, the rollers won't be able to compact the mix adequately. The mix should be about 115 degrees Celsius when it's delivered, because best compaction is obtained when the rolling is completed before the mat temperature drops below 90 degrees Celsius. Check your agency's specs for the minimum mix temperature requirements in your area. Then, record the mix temperature. Inform your supervisor and the contractor if you think it's too low or too high. You should also visually inspect the mix. You can tell a lot by its appearance. Some problems will require that adjustments be made in the batching or hauling of the mix. Some problems may be serious enough to outright reject the whole truckload. Later in part 3, we'll look at some examples of defective mix to help you recognize such problems. In any case, tell the plant inspector, the contractor, and your supervisor immediately if something doesn't look right. Along with your visual inspection, be sure to note the stationing from time to time so you can spot check how much material is being placed throughout the day. You do this by first totaling the weight of mix placed on the road as accumulated from the delivery tickets. Next, you determine the length of roadway paved from the stationing and multiply it by the width paved to get the total area covered. Then, divide the amount of mix placed by the area paved to get the yield. Your checklist has several sample calculations. A couple more rules about delivery of the mix. The first rule is the contractor should have enough haul trucks to maintain a constant supply of material to the paver. That way the paver moves forward continuously at the same speed. In addition, a constant supply of material means that the mix will be placed and compacted at a constant temperature, and that helps produce a good mat. Rule number 2 is that rule number 1 is nearly impossible on high-volume 2-lane roads. In these situations, even the best efforts to maintain a constant supply of mix to the paver may be frustrated by haul trucks stuck in traffic. The best solution here is to stop the paver quickly when stopping is necessary, and then to reach paving speed quickly when paving resumes. This helps to avoid depth changes and mat roughness as a result of variable paving speeds. Now let's take a look at mix placement, beginning with the conventional method. First, the haul truck should stop about a half meter from the paver so that the paver can move forward to contact the truck tires with its rollers. See that this contact is made smoothly and evenly. The haul truck begins to load the paver as the paver pushes the truck. Make sure the truck and the paver work closely together to avoid dumping mix outside the hopper. If you see material spilled ahead of the paver, make sure it's shoveled up so the tractor won't run over it. Another concern during placement is mix sticking to the sides of the hopper. What we want to avoid is cold, hardened mix mingling with good mix. Some people insist that the wing should be raised and lowered after every truckload. Others maintain that the wing should never be moved. Both arguments are valid, and either practice should be allowed, provided that only hot mix is used in the pavement. So if the wings are raised, there must always be ample mix on the conveyors for the wing material to mix with. When the windrow method is used, one of your main concerns is that all the mix is picked up. So see that the wings and the plate rest flat on the surface. If any material isn't picked up, have the contractor shovel it away from the wheels so it won't be run over by the pickup machine or the paver. From here on, your inspection concerns are the same for both methods. Check the overall quality of the mat. It should be smooth, uniform, and free of blemishes. If it's not, something is wrong with the paver or the mix. And look closely again for segregation. If the texture of the mat isn't uniform, the mix has segregated. Inform your supervisor and the contractor right away. Again, we'll look at some examples of mat problems in Part 3. Keep in mind that very few operations will run perfectly, so the important thing is for you to communicate. The depth of placement is also important. The contractor should make several loose depth checks using a depth gauge. A general rule of thumb is that the mix will compact about 20% in depth. So as an example, if the course being placed is supposed to be 60 millimeters thick, the loose depth should be about 75 millimeters. If changes in depth are necessary, the contractor should make the adjustment gradually. Both you and the contractor should then let the paver advance about 10 meters before rechecking the depth and making further adjustments. Where a shoulder is paved along with the adjacent travel lane, check the shoulder slope of the new mat. The typical section sheets will identify the proper slope, normally 5:1 or flatter. Now, before an adjacent lane can be placed, both the surface and the longitudinal joint have to be tacked. Then, after tacking, the second lane can be paved. The paver is lined up so that there's a slight overlap into the first lane. After the paver goes by, the joint should be ready for rolling. In some cases, however, a small amount of handwork may be necessary, using a lute to bump the overlapped mix back into the joint. When handwork is required, it should be minimal. Never allow anything like this. Now the joint can be rolled. We'll cover compaction in more detail later, but for now, just remember that longitudinal joints should always be rolled before any other section of the mat. Now let's look at grade and cross-slope control. You'll remember from Part 1 that the pavement grade is controlled by a sensing device with a long ski. You should watch the ski as the paver moves along. Make sure it pulls straight while remaining parallel to the longitudinal joint. If these conditions are met, The rest is automatic, for grade control anyway. As for cross-slope control, see that it's properly set and that the contractor checks it from time to time with a slope board. Be on the lookout for excessive cross-slope. That's just a waste of material. Now let's look at compaction. Compaction makes the pavement dense, so it will maintain its shape and have the required strength for traffic loads. Different types of rollers may be used and different rolling patterns may be followed from job to job, but all rolling must achieve the desired density, smoothness, and surface texture. Generally, there are 3 phases to rolling: breakdown, intermediate, and final or finish. Again, the equipment may vary, but a typical arrangement is for a steel-wheeled vibratory roller to perform the breakdown rolling, achieving much of the density required. Followed by a pneumatic tired roller to do the intermediate rolling. And then a static or non-vibratory steel-wheeled roller to provide the final or finish rolling. This last phase should remove all roller marks. On jobs where 3 or more units are not available, the rollers used should be operated to obtain full coverage and leave the mat with the required density and surface quality. Now here are some tips when you inspect the rolling. First, watch each roller as it reverses directions. It should come to a stop gradually and then reverse smoothly. And that one brief stop needed to reverse direction is the only stop permitted on the new pavement. The roller should proceed in as straight a line as possible. When turning is required, it should be done smoothly and gradually. The speed of rolling is also important. Rolling too fast can result in damage to the mat, so see that the rollers work at about walking speed. On super elevations, rolling should start on the low side. Each pass overlaps the previous pass 15 to 30 centimeters. The rolling progresses toward the high side to keep the mix from shifting to the low side. Remember though, longitudinal joints are always rolled first, regardless of their location. The density of the pavement may have to be checked too. Some agencies use nuclear density gauges similar to this one and require all gauge operators to be formally trained and, in some cases, certified. You should know that while it's important to roll the mat until it's dense enough, it's also possible to over-roll the mat. Too many roller passes may actually begin to reduce the density. After the pavement has been compacted and is cooled sufficiently, temporary pavement markings should be placed along the center line if the pavement will be open to traffic. These markings must be placed for the full length of the area paved by the end of each paving day. Now let's look at transverse joint construction. This involves making cold construction joints across the pavement perpendicular to the roadway center line. The joints are made when the contractor stops work at the end of the day, when the paving operation is delayed, or when bad weather is imminent. The first step in constructing a transverse joint is to cut away and remove the mix to a point where the mat has the required depth and slope. Since this is the point where paving will begin again, you need to be sure that the two mats will match up when paving resumes. Now, whenever the road is to carry traffic in the meantime, such as overnight, a temporary ramp must be constructed to provide a smooth, safe transition between the new pavement and the old surface. Sheets of paper are typically used in constructing these ramps, separating the mix that will form the ramp from the existing surface and the vertical face of the joint. Enough widths of paper must be placed to hold a ramp of proper taper, usually 20:1. Such a taper length won't jolt motorists as they drive over the joint. Mix is then placed on the paper, up against the joint face and extending to the full taper length. The joint and the ramp must be compacted the same as the rest of the mat. Rolling across the joint and down the ramp ensures that the end of the full depth portion gets properly compacted. Before paving can resume at the joint, the mix forming the ramp must be removed and properly disposed of. Then, be sure that the surrounding pavement is clean and the face of the joint is vertical. The face of the joint and the area where the ramp was made now have to be tacked. The primary concern when paving resumes is the transition between the previously placed mat and the new mat. So the crew typically places small strips of wood under the screed to make up for the difference between compacted depth and loose depth. After the paver goes by, see that any excess material is removed. Now the joint can be compacted. In the process, checks should be made with a straight edge to ensure that the transition is smooth. You should observe this check and have any high or low spots corrected. And those are the inspection points for transverse joint construction, which brings us to the end of this part of the videotape. Communicating with the plant, discussing operations with the contractor, and keeping your supervisor well informed are all part of good inspection procedures. This communication, along with the use of the inspection procedures and ideas we've discussed, will result in a well-constructed and acceptable project. In the third and final part of this videotape, you will see examples of problems that can and do occur with mixed quality, laydown operations, and rolling.